In this lecture, let's explore about system exception control registers. That is, control registers of the processor to control the system exceptions of the processor. Our processor has many peripherals. We have the nested vector interrupt controller, the FEU, the system control block, SysTick timer, the memory protection unit, debug unit, and various other peripherals are part of the processor. And they also come with their own register set to control them. All these register sets which control the functionality of a processor and processor specific peripheral are part of PPB, that is private peripheral bus region, which is accessed by the separate bus called PPB. The PPB region contains registers for all these processor specific peripherals: system control block, SysTick timer, NVIC, and lots of other things. Here you can see that if you find any address which starts from 0 cross E, then it mostly related to controlling processor or processor specific peripheral functionality. First, let's explore about system control block. So the system control block provides system implementation information and system control. This includes configuration, control, and reporting of the system exceptions. Basically, as its name indicates, system control block contains registers to control and configure some of the system specific functionalities of the ARM Cortex-MX processor. Like, you can configure the system exception, you can enable them or you can disable them, you can configure the priority for them, and various other things. Let's explore the registers of the system control block from the generic user guide. I'm in the generic user guide, and you can go to this section 4.1. Then you get the address map of the private peripheral bus. So I actually took that image from this document itself. Let's go to system control block. Here it is. You can see that system control block contains all these registers. We need not to explore each and every register, but let me just talk about few registers which are very much helpful. You can see that your system handler priority registers. These registers are used to configure the priority for the system exceptions. Remember, we don't configure any interrupts from here. Interrupt is part of NVIC. NVIC will handle that. SCB is for system exceptions and for other control related settings. And you can see that if there is any fault exception, so about fault exception I'm going to discuss later in this course. If any processor fault happens, then the status of the fault is captured in the fault status register. There are many fault status registers like memory managed fault, bus fault, usage fault, hard fault. All those, the fault status, that is at what address the fault happened and what was the cause of the fault, everything is logged in these registers. And after that, there is also one register called system handler control and state registers. By using this register, you can enable various system exceptions like usage fault exception, bus fault exception, mem fault exception, and various other things. Basically, if you want to do any system exception configuration or vector table offset configuration, or if you want to set priority for any system exception, or if you want to do any other system specific settings, then SCB is a place to check. Please keep that in mind. By using SCB registers, you can enable fault handlers, you can get pending status of the fault exceptions, you can trap processor for divide by zero and unaligned data access attempts. You can even control the sleep and sleep wake up settings by using SCB registers. You can configure the priority of system exceptions, and you can also control the SysTick timer of the processor. That's how we can use the registers of the SCB. Actually, we have 15 system exceptions, but some are not implemented. They are reserved. Totally, we have 9 system exceptions from hard fault to debug monitor exception, in which hard fault is always enabled. So you can mask it, you can disable it, but by default it is always enabled. NMI, you need not to enable anything. It is always enabled. You can't mask it. Whereas usage fault, memmanage fault, bus fault, systic, SVC, pendsv, debug monitor, all these exceptions are disabled by default. For example, if you want to trigger SVC exception, then you have to execute SVC instruction. I will cover that later. If you want to get systic exception, then you have to trigger the systic timer. If you want to get a pendsv exception, then you have to enable it. Most of the system exceptions are disabled by default. You should remember that hard fault and NMI exceptions are always enabled. That's about system control block, and in the next lecture I will cover NVIC. I will see you in the next lecture.